Hello everyone, my name is Arti Siddhpura and today I'm going to show you this gasoline engine section model. So this is a 4-cylinder Toyota 8A petrol engine. It is a 4-cylinder because you can see here there are 4 cylinders and 4 pistons. Now let's begin with the powerhouse of the engine. Let me show you the piston. Alright, so as you can see here, this is the piston. So there are 4 such pistons in various different positions. Now pistons and cylinder all together, they are the main components of any 4-cylinder petrol engine. Alright, so let me explain the stroke first, why it's called 4-stroke engine. So as you can see here, the piston goes up and moves all the way to the bottom. So that is called 1 stroke. So as piston moves from bottom to top or top to bottom, it completes 1 stroke. Now why 4 strokes? Let me explain each stroke one by one. So let's say piston starts moving from top to bottom. That is when the vacuum is created inside this space, and that's when fuel-air mixture enters into the space. When piston moves up, it compresses this fuel-air mixture. Now when the pressure reaches certain value, there is a spark plug. Spark plug will ignite that compressed mixture, and due to the combustion of the fuel, it will push the piston down. This is the most important stroke, I would say, because it's called the power stroke. And then when the piston moves one last time from bottom to top, it will push away the combustion products through the exhaust manifold. So these are the 4 strokes. Keeps moving top to bottom and bottom to top. This reciprocating motion actually gets converted into the required rotary motion through the crankshaft. So we have connecting rod here, connecting piston with the crankshaft, and crankshaft has got those counterbalancing weights. They will balance the crankshaft against the piston so that we have smooth rotary motion going into the car or any engine. Now the firing order, because you can see there are 4 such cylinders, and there is a reason why there are 4 such cylinders, because at any given point in time we want to have at least one cylinder going through the power stroke, so that some sort of power is being generated, and that is done through the firing order. So firing order for this particular engine is 1, 3, 4 and 2. So as I start this, you should be able to see that power stroke will happen in the cylinder number 1, then 3 will go through that, then 4 and then 2. So that is the firing order here. Now let's have a look at the camshaft. So here we have the camshaft along with cam gears and timing belt. On the camshaft, as the name suggests, we have cams. And what do the cams do? They take care of the intake port and the exhaust port. So they maintain the timing so that exactly at the right time fuel-air mixture will go into the cylinder, and at the right time the exhaust port will open so that exhaust products can go through the exhaust manifold and away from the engine. So that is your camshaft along with the cam gears, timing belt, etc. Alright, so cylinders, because this is a cutaway model, because we want to show how it looks from inside, but they are not open like this. The bottom part is sitting inside the engine block, so engine block has crankshaft and cylinders and those things, while the top part over here is the cylinder head, where we have valves, cams, all those things are incorporated inside the cylinder head. On one of the ends of the crankshaft, as you can see over here, this is the flywheel. Now flywheel, what does it do? Flywheel is more like a reservoir of energy. As we know, we have only one power stroke, and one power stroke has abundant amount of energy. But rest of the strokes, they don't get any power. So we want to make sure that when there is lack of that sort of energy, the reservoir kicks in and it supplies the required energy from there. So that's the flywheel. Now we have air intake here. So air goes through the air intake, air filter, and inside this it will go through the intake manifold where it will mix with the fuel. So these are the fuel injectors. So air and fuel mixture will be injected inside the cylinder through these injectors. Then we have spark plug here. So as I was talking about the spark which will be needed to ignite that compressed air fuel mixture, these are the 4 spark plugs. Alright, so this is the alternator. Alternator actually converts the mechanical energy into the electricity. Now electricity is needed for charging the battery, which will help us turn on the car. Apart from that, there are many other electrical systems inside the car that will need electricity, and that is provided through this alternator. The next part I would like to show is this oil system. So the whole engine requires a lot of lubrication, cooling, and oil is needed for all these purposes. So oil has a separate reservoir, pumping system, filter, and all those things, and it has its own circulation system. The last bit of the engine is this exhaust manifold. So exhaust manifolds, as you can see, the exhaust products will come through this exhaust manifold and it will get collected into this one particular pipe. From there it will go through the catalytic converter, which will capture the toxic chemicals, and then it will go all the way to the muffler, which will reduce the noise of the exhaust gases coming out of the engine. And that completes this entire 4-stroke petrol engine. Right, so nowadays, as we all know, fossil fuels are being phased out because they are not so good for the sustainability. And here I'm showing you the petrol engine. You might ask me why. But this is just the principle, I would say. Even the hydrogen engine or any other similar sort of engine will work on the same principle. The pistons have to be there, the cylinder, they have to be there. So principle still remains the same, and I hope you will find this helpful in terms of understanding the principles.